These are some very important conclusions. So what we have now, I think regarding dipole, we have a very good, better picture is there. What is that like? The field on the axis, we know it. On the bisector, we know potential on the axis on the bisector. Now, means now an atom. What is the field due to an atom? What is the potential due to an atom surrounding outside, external to the atom? Can we find out? Yes, we have a picture like this. We have some better information. We have a set of formulas also. Okay, let's come for this one. How to calculate at point 8, any arbitrary point, the potential as well as the field strength. I'll go to the next part. This is the same thing what we discussed. I'm just bringing a set of formulas. If we have the dipole moment, this is A, this is Q. So what is the electric dipole moment? Distance of separation between them into charge of the particle. At point P, I want to find out the electric field strength. Okay, let this theta. What is R? R bar is a position vector. So here we'll do one thing. Let me write L, because A I'll be using for some other thing. Okay, at point A. So let's find out the electric field strength and electric potential. So first, what is the expression for potential at point A? It is given by VA is equal to P by 4 pi epsilon naught R square. This, if you want, we can derive. Okay, directly let me start with this information. So how it is brought? How it is brought? So the same approach here. I'll assume at a distance R, then using I'll find out this distance. Then I'll find out the potential at point A due to positive charge. Then potential at point A due to negative charge. I know this distance. Then I'll take the algebraic sum. The expression for that is given by this particular formula. Agree? No? So now if I know potential, can I find out the field? There are two parameters are there. There are two parameters are there. One, component of field directed along the position vector, and a component of field that is directed perpendicular to this one. So this will call E parallel. This is E perpendicular. The resultant field will be directed. I'm slightly deviating away. Will I agree? There will be a field at point A due to what? Due to positive charge and negative charge. The resultant of that is what? This E bar. But here we have some method. This is called like a polar coordinates method, which is not there for syllabus, but I think I'm just writing the formula so that it will be very easy for us. Otherwise, what you should do, you should enjoy the mathematics. Calculate first E plus, next calculate E minus, then take the vector sum. First calculating E plus itself is a very big headache. It will take easily 1 hour. Instead of this mathematical approach, I'm directly going for one using polar coordinates, and directly start with potential at point A. We know this also. If you want, you can derive. Let me directly begin with this one. I think in a NCERT book he has given this derivation also. I'm going to start with the derivation. How to get the E parallel with the help of this one. So you know, yesterday we had a discussion of yesterday E equal to minus dou V by dou R. We discussed, no? Yesterday the electric field, if you know potential, you can get the electric field. Similarly, that one. With the help of this, what happened? We can easily predict the electric field. One more thing. Sorry, this one. Cos theta. First of all, we'll define what is theta and R. What is R? R bar is the position vector. What is theta? angle between R bar and P bar. What is theta? Angle made by the position vector with the dipole moment vector. So where is the dipole moment vector? The dipole moment vector will be oriented along x-axis. So like this we define, and what is theta equals 0 degree line? Theta equals 0 degree line is this one. Do remember, and this is theta equal to 90 degrees line. Bisector will be theta equal to 90 degrees, and axis will be theta equal to 0 degree. So the first will get the E parallel. What is E parallel? E parallel is given by minus dVA by dr. If you differentiate this with respect to R, you get the E parallel. Okay, let me differentiate P cos theta as it is minus this will become 2 by R cube. So this will become minus 2p cos theta by 4 pi epsilon naught R cube. This will be the component of electric field directed along position vector. In the books, they called this as a radial vector. Like a radial electric field. Then there's a normal electric field, radial electric field, they called it. Let me directly call only E parallel. So next, how to get E perpendicular? E perpendicular is given by 1 by R dV by d theta. Same thing. Differentiating this potential function with respect to theta, we'll get this E perpendicular. So this will become minus 1 by R. Differentiation of this will be minus P sine theta 4 pi epsilon naught R square. So this will become just only 1 by R, no, it is. Okay, this will be positive. Some signs you take care of. So this will become P sine theta try to see this. We know potential at point A. Then to get this like a component of field along position vector, I'll differentiate with respect to R. Fine. So after derivation, all will end up with this one. To get the perpendicular component, I'm going to differentiate with respect to theta. This is not V theta, VA. Okay, see once. Better I suggest you remember this. And to get the E parallel, E perpendicular, there's a formula. If you can remember, that'll be sufficient. Now, okay, what is the thing? So we have to get the resultant field. So what is the resultant field? E perpendicular square plus E parallel square. P sine theta 4 pi epsilon naught R cube whole square I think the P by 4 pi epsilon naught R cube you can take outside everything. This will end up with sine square theta 4 cos square theta. Can I simplify further? 4 pi epsilon naught R cube. This will be 1 plus 3 cos square theta. This is the expression for the electric field strength at point A. No, what is theta? Okay, let's do one thing. Shall we verify it? Shall we verify back? Means whether this is right or wrong. Whether this is right or wrong. So what we'll do, we'll put theta equals 0. If you put theta equals 0, what is the answer? We should get 2p by 4 pi f naught R cube. Put theta equals 0. 1 plus 3, 4. Under root like a root 4 will be 2. So 2p 4 pi f naught R cube. Then we know on the bisector, what is the field strength? Should be only p by 4 pi f naught R cube on the bisector. Put theta 90. Then on the bisector P by 4 pi epsilon naught r cube. Then anywhere at any arbitrary angle theta, the field strength is given by this particular formula. Okay, this is about the magnitude. So what about the direction? How you are going to get the direction? I think I'm very sure now. So the resultant field is this red color one. No? So I got the magnitude. What about the direction? See how to get this particular angle. So I'll take help of the vector diagram. This will be E parallel. This will be E perpendicular, and this is the resultant. So tan phi, what we can write it as? Tan phi equal to E parallel by E perpendicular. What is E parallel? E parallel will be, I need some space. E parallel, we can define it as 2p cos theta 4 pi epsilon naught r cube. P sin theta 4 pi epsilon naught r cube. So I'll end up with the formula 2 tan theta. There's a relationship between the electric field vector. This one. So what is the tan phi? Tan phi. Opposite by adjacent. I'll make changes. Thank you for correction. Yeah. This will become tan theta by 2, not tan of theta by 2. Tan theta all divided by 2. Okay, there's a relationship between this one. So now say whenever we have a dipole, what will be given for us? We'll be having the dipole moment. This will be known. I know where I'm going to calculate the field, and I know this theta. So with this, what happened? I'll get this angle phi. What is this angle made by the resultant E bar with the position vector? I know it. No, what is the angle made by E bar with the dipole means? It should be theta plus phi. So what is theta plus phi? What is the like a phi we should define? Angle between E bar and R bar. Then what is theta plus phi? We should call it as angle between E bar and P bar. So how much of electric, what is the direction of electric field with respect to dipole moment? The theta plus phi will be the angle between the electric dipole moment and the resultant E bar. I think this is a better formula, no? Instead of doing the earlier part, we could have directly come, we could have arrived here. This will be, sir, like how you brought this equation. I'm telling this one, it's there in the NCERT book. Again, I had to spend around 10 or 15 minutes, which may not be very important. So I'll directly writing this formula. From there is what we have this one. These are things, sir. How come you say these are correct? Because it is justifying the earlier answers, no? These are like a finding out electric field using polar coordinate. By varying r and theta, I can choose any point surrounding dipole. Are you getting? By varying r and theta. Now I want on the axis at certain distance. So what is the theta? Theta will be 0. Put theta 0. Then what is r? R will become r. You are going to measure along the axis. This one. So by varying r and theta, you can define any point surrounding a dipole. And you'll get both the magnitude as well as direction. I think this will be really, really going to help you a lot, especially for exams. No, this method is very important. Even if you have forgotten these formulas, if you can remember this, I think somehow you can manage all. Any doubts, you can please clarify it.